All right, so this one says a particle is moving along the x-axis, times are positive, position is given by this function. When is the particle at rest? So at rest means that it is not moving, and so that's going to be velocity equals 0. So I'm going to get the velocity, set it equal to 0. And so velocity is going to be the derivative of position. So the derivative of this function would be 6t squared minus 42t plus 72. And again, we're setting it equal to 0 because it said at rest. And so I'm going to go through and divide everything by 6 just to kind of make these numbers a little bit smaller here. And 0 divided by anything is still just going to be 0. So still just equals 0. And then we're going to factor. So this is going to split t minus 3 and t minus 4. And so the times we get are 3 and 4. And so that one is E. All right, number 2. A particle moves along the x-axis. Times are positive. Velocity, all right, they gave us velocity this time, is given by this crazy function. What is the acceleration at time 4? Now, I know I'm going to need a calculator because all these answer choices are all these crazy decimals, so I know I'm going to need a calculator. This is velocity. To get to acceleration, we're going to need to do a derivative. So to get from velocity to acceleration, that's a derivative, and we want the derivative at 4. All right, so take a calculator for this one. Hey, guys. How do I do a derivative on my calculator? What menu am I going to need to go under? Good, math. And it's math 8. Nice job, math 8. So if you want to follow along with me, hit math 8. I know the problem says t, but I'm going to type x. So d dx, and then the function goes in those parentheses. So that is 3 plus 4.1 cosine of 0.9x, and then at the end we want such that time is 4. And it will literally just give you your answer. So 1.633. And you guys were typing a lot of stuff in the chat at once. I wasn't really able to like catch all of it, but I think somebody had typed something of like, just take a problem and like put it in the calculator. The only thing I'm going to say about that is be careful, because you know a good portion of the AP exam is non-calculator, and you're going to have to be able to do stuff without it. Like this one was calculator because we had all these decimals here, but I would just be wary of trying to put everything in the calculator, because then you're not going to learn how to do it without it. So that's all I'm going to say about that. All right, so that one is C. Oh, I'm sorry. Okay, I didn't understand that then. There's one that shows steps. So like, what do you mean? Like when you, I don't know what you mean by shows steps. Like the actual work of the problem? Oh, can you put the link for that in the chat, please? Because I'll post that to Schoology if you have one. Like someone post the link and I'll go and post it to Schoology when we're done here. All right, number 3. Position of a particle moving is given by this. So they give us position. It says what is the acceleration at time 4. So we can't jump straight from position to acceleration. We're going to have to get the velocity first. So derivative of this is 2t plus 4. And then the acceleration would be the derivative of that, which would just be 2. So this is kind of tricky because the answer is actually just 2. It doesn't matter what time they said. Like they said time 4, they could have said time anything. It doesn't matter. The answer is just always going to be 2. All right, number 4, a particle is moving, so the position is given by this. When is the velocity 0? So we're going to find the velocity, set it equal to 0. So this derivative would be 2t minus 6. And we're going to set that equal to 0 and solve. So we'll add over the 6, divide by 2, and so that one is C. All right, this one, I wrote the problem a little bit bigger. If you want to open this homework in another tab on Schoology and change your zoom to like 300%, you'll be able to see it real well. I just wrote it bigger here so that we can see it a little bit better. All right, particle is moving. This is our time interval, 0 to pi. Position is given by this function. What is the velocity when the acceleration is 0? So instead of saying what is the velocity like at time 3, they don't give you that time. We are going to have to set the acceleration equal to 0 to get that time. So we're going to need both velocity and acceleration for this problem. And see all these decimals? This means I'm going to need a calculator. So derivative of cosine would be negative sine. So the negatives are going to cancel. This will just be 4 sine of t minus. Now when we do the power rule for this, when you bring the 2 down, the 2's are going to cancel. And when you drop a power, it will just be t to the first. So just minus t. And then 10 is a constant, so that's gone. And then acceleration, derivative of velocity. So derivative of sine is cosine, and derivative of t is just 1. And it said, what is the velocity when the acceleration is 0? So I'm going to set the acceleration as 0. Once I get this time value, I'm going to plug it back into velocity. We want, what is the velocity at this time? So I'm going to add over this 1. Oh, and if you're having trouble seeing it, open it in another tab and change your zoom to like 200 or 300%. You'll be able to see it like clear as day. You just have to make the zoom like really large. Oh, don't spend an hour and a half on one question. It's not supposed to be that. Just zoom in or email me and I'll get back to you. All right, and then I divided over this 4. So I can't solve this without a calculator because 1/4 is not on the unit circle. If this came out to like square root of 3 over 2 or square root of 2 over 2, you know, then I'd be able to do it without a calculator, but I am going to need my calculator. So cosine is going to go in y1, 1/4 is going to go in y2. Oops. And we're going to calculate where they intersect. Now, before I hit graph, remember the window we were given was 0 to pi. So I'm going to go to window and make that 0 to pi. Oh, not 0 pi. 0 to pi. There we go. And it really doesn't matter what the y values are. You can kind of make them whatever you want as long as you can see the graph well enough. All right, so here's cosine. That's a wave. We're only seeing part of it because of the window. And then that's 1/4. We want this intersection. So I'm going to go to calculate, which is second choice. Intersect, and then it's going to ask you first curve, second curve, guess. Basically just hit enter a bunch of times. And that is our time, 1.318. Now, because they are super evil, that's an answer choice over here. We're not done with this problem, but that is an answer choice, so just be really careful. They asked, what is the velocity at that time? So you have to take this 1.318 and plug it back into velocity. Now here's what's kind of cool that your calculator will do. As of right now, it has x stored as this number. So if you go back to your home screen and just retype the velocity and put the x in there, it will plug it in for you, which is kind of nice. So I'm going to type 4 sine of x minus x. And like I said, it has x stored as that 1.318, so it's going to like copy and paste it in there for me. And that is my answer. So 2.55. All right, number 6. A particle moves along the x-axis. Position is given by this. A and B are constants. That means they're just a number, and A and B are not equal to each other. So for which of the following values is the particle at rest? Okay, so guys, what does at rest mean? How do I do at rest? All right, good. Velocity equals 0. So we're going to find the velocity and then we'll set it equal to 0. Nice. Now this is going to be a product rule since we have two functions here. So it's going to be the first, which is t minus a, times derivative of the second. Well, derivative of t would just be 1, and b is a constant, so that's gone. So first derivative of the second plus the second times derivative of the first, which would also just be 1. And we're going to set that equal to 0. So basically you can ignore these ones. I'm just putting them in there to show you that it's a product rule, but timesing by 1 isn't going to change anything. I'm going to put the like terms together. So t plus t would be 2t minus a minus b equals 0. And then I'm going to add over the a and the b. And then we're going to divide by 2. So a plus b over 2. So that one is b. And then last one here. Position is given by this. I wrote it bigger so that you guys can see it a little bit better. Again, if you want to open this in another tab and change your zoom, you can see it there too. Times in seconds in the first 4 seconds. Okay, hold on to that because that's going to come up again later here. In the first 4 seconds, how many times is the velocity equal to 0? All right, so we're going to find velocity and then we'll set it equal to 0. So derivative of cosine is negative sine, so negative 1/6 sine 5t, and then I have to chain on the derivative of 5t, which would be 5. Instead of putting times 5, I'm just going to go ahead and put that 5 in the numerator here, so this is a little bit less cluttered. All right, minus derivative of sine is cosine. And same thing, I need to do a chain rule for the 5t, and I'm just going to put that 5 in the numerator here. You can write it like times 5 off to the side if you want, but I just stuck it in the numerator of the fraction. And we want to set that equal to 0. Now, they didn't ask for the times. We just want to know how many there are. So we're going to put this into y1 in our calculator. So it is negative 5/6 sine 5x minus 5/4 cosine 5x. And remember that thing I said was going to come up later? I underlined it up there. We're looking at the first 4 seconds. So I'm going to go to window and make it be 0 to 4 and hit graph. Now, all this question asked for was how many times does the velocity equal 0? So once this is done graphing this here, hey guys, how many zeros are on this graph? Because that's what we're being asked for. So just how many are there? And good, there are 6. 1, 2, 3, 4, 5, 6. And so that one is D.